So there are three concepts I believe every photographer should understand in order to intentionally create good photographs. Understanding exposure, how to see light, and how to create effective or interesting compositions. In this lesson, we're going to take a deep dive into truly understanding exposure. What it is, what are the elements that make up an exposure, and the creative implications that each exposure setting has on the final image. Okay, so first things first, what is exposure? Well, in the simplest terms, exposure is the amount of light that reaches your camera's image sensor, and this directly determines how bright or dark a photo will be. On your camera, there are three different settings that can either be controlled by you or automatically by the camera's auto exposure modes, and these settings are shutter speed, aperture, and ISO. And technically speaking, the correct way to pronounce ISO is ISO, but I've been saying ISO for at least 10 years now, and it's a little too late for me to change this habit, so bear with me. So the shutter speed is the amount of time that your camera sensor is exposed to light. The time is measured starting when the camera shutter opens, and it ends when the camera shutter closes. The shutter speed is measured in seconds, with the most common shutter speeds being a fraction of a second. For example, 1/250th of a second. For longer lengths of time, which are called long exposures, this would be 1 second or more, say in a long exposure of 30 seconds. The aperture is the size of the lens opening that is letting in light to your camera's sensor. And the measure of the aperture size, which is called the f-stop or f number, is actually a fraction, so f over the aperture number. The larger numbers like f16 are for smaller openings which let in less light, and the smaller numbers like f1.4 are actually for larger openings which let in more light. And when you're changing the aperture, what you're really adjusting is how close or open the aperture blades of the lens are. Okay, so now for ISO. In order to really understand ISO, we need to explain camera sensors a little bit. So as opposed to film, which was made up of chemicals that react to light, in digital photography, your camera sensor is essentially an array of photodiodes, one for each pixel. And photodiodes are basically little devices that turn light into an electric signal or charge, which is what makes digital photography possible in the first place. So in the film days, ISO referred to the chemical sensitivity of the film in reaction to light. So higher ISO meant higher sensitivity. In the digital world, ISO is the gain or the amplification value of the electrical signal created by the photodiodes. So a higher ISO in this case means a more amplified signal, which for all intents and purposes means, again, higher sensitivity to light. So how does all this work together in order to make up a photo's exposure? Well, the most effective and probably the most popular analogy to teach the exposure triangle is the act of filling up a glass of water. For this lesson, let's say a scene's proper exposure is when the glass is filled to the top. The shutter speed here would be the length of time that the faucet is on. Turning on the faucet is like the shutter opening. The longer the faucet is on, the more water fills the glass. The longer the shutter is open, the more light hits the sensor. And when the faucet is turned on, this is essentially closing the shutter. The aperture would basically be the size of the nozzle of the faucet. The larger the faucet opening or the spout is, the faster the water flows. So the larger the lens opening, the more light is let into the camera hitting the sensor. Conversely, you can have a smaller nozzle and this would take longer amount of time to get the same water level in the glass. And ISO would pretty much be the size of the glass itself, basically the amount of light needed for that proper exposure. The smaller the glass, the less water is needed to fill it to the top. So the higher the ISO, the less light is needed for the proper exposure. And then underexposure would be when there's only a little bit of water in the glass, or essentially a dark photo. And overexposure would be when the glass is overflowing or a photo that's too bright. Got it so far? All right, cool. So far we've only applied this analogy to continuous lighting sources. So natural light, ambient indoor light, or even constant video lighting such as LEDs. But in photography, we also have the capability to use flashes or strobes. And flashes serve as a way to quickly inject light into the scene thus aiding the exposure, especially in low light situations or studio scenarios. And for this particular analogy, dumping water from another glass would be the equivalent of instantaneous light output from a flash. So in general, balancing the exposure triangle to get proper exposure can actually be achieved in a number of ways, just like how you can fill a glass of water to the top using a number of approaches, filling the glass for a long time with a slow stream of water, or filling it quickly with a higher flowing water flow. It just comes down to your approach and your preference. But now this begs the question, how exactly do we decide what exposure settings to use and how do they affect the look of the final image? Well, this brings us to the actual creative implications of each of the exposure settings aside from just making the image brighter or darker. When it comes to shutter speed, a low or a slow shutter speed will introduce motion blur of the scene and the subject. This comes useful for those instances when you want to convey a sense of motion. For example, a panning photography shot or light trails or light streaks. On the flip side, a high or fast shutter speed is great for freezing fast-moving things or high-speed actions. So sports, vehicles, dancing, running kids, etc. Again, action and freezing motion. For aperture, a low f-stop number or a large aperture opening will give you that smooth background blur or shallow depth of field. You know, that look that everyone's looking for when they're finally graduating from iPhone or mobile phone photography and going over to a DSLR or mirrorless camera. The depth of field is essentially the distance between the closest and furthest objects in the scene that are sharp or in focus. So a shallow depth of field has a small number of things in focus, usually just the subject, with the stuff to the front and back of the subject out of focus or blurry. A high f-stop number, on the other hand, or a small aperture opening will give the opposite effect. This will give you a deep depth of field, so the distance range of things that are in sharp or in focus is a lot longer. But because mostly everything will be in focus, sometimes this will even cause any dirt or dust on your camera's sensor or on the lens to be visible in the image, so be sure to watch out for that. For ISO, I like to think of this like an electric guitar's amplifier. So with low gain, the guitar has a cleaner sound and more tonal range. With higher gain, on the other hand, the sound is more distorted and noisy. For photos, a lower ISO will lead to cleaner images, minimal noise, and higher dynamic range, which is basically the range between the darkest and lightest parts of the image. A higher ISO, on the other hand, is generally useful for low light images or situations when you need the shutter speeds to be really fast, but this will be at the expense of noise or digital grain in your image and reduced dynamic range. So on Fujifilm cameras, there is a native ISO range, which is the standard gain, and then there's also an extended low or high ISO ranges which have additional processing on them. And this tends to reduce the image quality. So just remember and keep that in mind when you get into those extended ISO ranges. So to wrap this lesson up, let's talk about how we actually measure exposure. Exposure is measured in stops of light. An exposure stop is either 2 times decrease or increase of light. So an increase of 1 stop would actually be 2 times the amount of light, and a decrease in 1 stop would be the light cut in half. And going back to our glass of water analogy, increasing the exposure 1 stop would be doubling the amount of water. And then decreasing the exposure 1 stop would be cutting the amount of water in half. And while you don't have to memorize these values, it's good to be familiar with the full stop values of each exposure setting. So these are the full stop values for shutter speed. And here are the full stop values for aperture. And these are the full stop values for ISO. And then finally, the full stop values for flash power. And distance also plays a part in kind of measuring the exposure and light values. The inverse square law is applied to light. So basically, 2 times the distance from a light source will actually result in 1/4 of light intensity, or doubling the distance from the light will decrease in 2 stops of light. So this comes in handy for any type of off-camera flash scenario, or if you have a specific light source that you're working in relation to with distance. So exposure stops come in handy when you need to come up with equivalent exposure values for a specific situation. For example, if you dialed in the exposure but needed a faster shutter speed for sports coverage, you can have 1 stop faster shutter speed and then increase the ISO by 1 stop to compensate. Or say maybe you're shooting an event and you need to stop down the aperture one stop for more depth of field to get more things in focus. You would need to increase the flash power by one stop in order to compensate for the same amount of light in that scene. Okay, so we covered a lot in this lesson, but feel free to watch this over as many times as you need to let the concepts really soak in. But in general, the best way to understand all these exposure settings is actually to just change around, experiment, and take photos with all the different settings and actually see how they affect the final image for your photography.